Hello guys, welcome to Dr. Science. So today we are going to talk about the different types of porphyria. So please watch my first part and second part, since I already talked about the cycle of the synthesis of the porphyrin ring. So first I will start with the basics. So in my previous video I already talked about how porphyrin ring is synthesized. So in the presence of glycine plus succinyl CoA, this glycine and succinyl CoA gets converted into a compound called as your amino levolunate, or we can simply call this as ALA. Now the enzyme here responsible here is your amino levolunate or ALA synthase. Which is vitamin B6 or pyridoxal phosphate dependent. Now amino levolunate eventually gets converted into a compound called as porphobilinogen, which is a precursor of your pyrrole ring. Now the enzyme responsible here is your ALA dehydratase, because during this process water is going to get kicked out, hence dehydration is happening, right? So the enzyme responsible is your ALA dehydratase. Now this ALA dehydratase can be inhibited by a compound called as your lead. Now lead, it is mainly used in treating your bipolar disorder or any other neuropsychiatric disorders. Okay, if these people are taking a lot of lead, this lead can inhibit the ALA dehydratase component. Hence what will happen, ALA cannot be converted into porphobilinogen. So this ALA gets accumulated into your brain tissue or other tissues. Hence these patients will be having neurological deficits or neuropsychiatric problems. Okay, now this type of porphyria is called as your acquired porphyria. Since this is not congenital, we are acquiring it through lead poisoning, hence it is called as your acquired porphyria. Next, the porphobilinogen will eventually get converted into a compound called as your hydroxymethyl bilane. Now the enzyme during this process water is going to get added into this compound, hence the name hydroxy. Hydroxy means you can remember like water is getting added, so hence hydroxymethyl bilane. And the enzyme responsible here is your hydroxyl methyl bilane synthase 1, or the other name is uroporphyrinogen synthase 1. Now deficiency of this enzyme will eventually lead to a disease called as your acute intermittent porphyria. Okay, so now we will go to the next step. This hydroxymethylbilane will eventually get converted into a compound called as uroporphyrinogen. Let me clear this one. Uroporphyrinogen type 3. Now the enzyme responsible here is your uroporphyrinogen synthase 3. Now deficiency of this uroporphyrinogen synthase 3 will land into a porphyria called as your congenital erythropoietic Porphyria. Okay, so what will happen if the hydroxymethylbilane is not getting converted into uroporphyrinogen 3? The hydroxymethylbilane will get accumulated into your brain and tissues. Hence these people will also have neurological problems or neuropsychiatric problems. Okay, now the next step is conversion of uroporphyrinogen into a compound called as your coproporphyrinogen type 3. Now the enzyme responsible here is your, let me tell you something. During this process carbon dioxide will get kicked out from here, so the enzyme responsible here will be a decarboxylase. Since decarboxylase will do decarboxylation, hence the enzyme name is decarboxylase. To be more specific, the enzyme name is uroporphyrinogen decarboxylase. Now what will happen if there is an enzyme deficiency of uroporphyrinogen decarboxylase? The condition is called as your Porphyria cutanea tarda. So what will happen when the uroporphyrinogen is not getting converted into coproporphyrinogen 3? Now many of the people may think uroporphyrinogen will accumulate into your brain tissue, but that is not the same case, because uroporphyrinogen type 3 can go into a sideway pathway. This is a sideway pathway which is not present in the above cases. So uroporphyrinogen can go into a sideway pathway and eventually it get converted into a compound called as uroporphyrin type 3. Okay, and this happens in the presence of light. It means there is this light which is coming from your maybe sunlight. It is converting uroporphyrinogen into uroporphyrin 3 via spontaneous oxidation. Now the spontaneous oxidation is converting uroporphyrinogen, which is this compound, into uroporphyrin 3. Now this uroporphyrin 3 is a defective porphyrin. Okay, why this is a defective porphyrin I will say. Now this uroporphyrin, instead of writing uroporphyrin I will just write porphyrin. Okay, this defective porphyrin in the presence of spontaneous oxidation by light. Now what is meant by this? Suppose this is the porphyrin ring. So this is the porphyrin ring which is defective. Now this porphyrin ring which is defective can absorb light. There is a sharp absorption of light. Especially at 400 nanometers. Now suppose this is a graph. So at 400 nanometers there is sharp absorption of light. Now this band here is called as your Soret band. Which was described by a French physicist called as your Soret. Hence the name the Soret band. So what happens when there is a sharp absorption of light? Due to spontaneous oxidation, there will be release of oxygen-free radicals. And once oxygen-free radicals are released, there is tissue damage. Hence these patients, compared to other enzyme deficiency, instead of having brain damage, these people will be having photosensitivity in their as clinical features. Okay, so once again, deficiency of uroporphyrinogen decarboxylase will lead to uroporphyrinogen getting converted into uroporphyrin 3 in the presence of light. Okay, so once again I will draw it here in order to clear the clutter. So uroporphyrinogen 3 will take a sideway pathway in the presence of light, which will lead to spontaneous oxidization and formation of your uroporphyrin 3, which will absorb the light and eventually leads to release of oxygen free radicals. Hence these people will present with photosensitivity. So uroporphyrinogen was getting converted into coproporphyrinogen type 3, okay, by the enzyme called as your decarboxylase, which is uroporphyrinogen decarboxylase, and deficiency of this will land to a porphyria called as Porphyria cutanea tarda. Okay, now this coproporphyrinogen will again get converted into a compound called as your coproporphyrinogen is getting converted into a compound called as your protoporphyrinogen type 3, and protoporphyrinogen will eventually get converted into protoporphyrin type 3, and this protoporphyrin will eventually get converted into a compound called as heme. So during this conversion of protoporphyrin 3 into heme, iron is getting added, and the enzyme responsible here is your ferrochelatase. Now this ferrochelatase is an enzyme which can be inhibited by lead poisoning again. Okay, so lead poisoning can inhibit two compounds. Lead poisoning can inhibit two enzymes. The first one was your ferrochelatase, and the second one was your aldehydatase, which was seen in the first reaction. Okay, and hence lead poisoning will lead to acquired porphyria. Now what are the enzymes responsible of converting coproporphyrinogen into protoporphyrinogen? The enzymes are oxidase and protoporphyrinogen into protoporphyrin 3. The enzyme here is also oxidase. Now deficiency of this oxidases will eventually lead to the same pathway. Okay, eventually lead to the sideway pathway. Hence there will be instead of writing protoporphyrin, I will just write porphyrin synthesis, defective porphyrin synthesis, which will lead to spontaneous oxidation of light, and hence these people will be having photosensitivity. So basically what I am saying is everything below here, everything which is starting from here to here, the enzymes, either it can be uroporphyrinogen decarboxylase or your oxidases or your deficiency in ferrochelatases, all these people will be having photosensitivity as their clinical feature, whereas everything above uroporphyrinogen type 3 synthesis will have neurological manifestations. Okay, so let me start with the let me start before going to the diagrams above. I will start with the summary what we have discussed until now. So what will happen in lead poisoning? In lead poisoning, there will be inhibition of two enzymes, which is your ALA dehydratase and not only that, there is ferrochelatase inhibition. Ferrochelatase. So this type of porphyria is your acquired porphyria. Next we will talk about deficiency of uroporphyrinogen synthase 1. And deficiency of uroporphyrinogen synthase 1 will eventually land into acute intermittent porphyria. And deficiency of uroporphyrinogen synthase 3 will lead into congenital erythropoietic porphyria. And finally, deficiency of uroporphyrinogen decarboxylase will land into a condition called as Porphyria cutanea tarda. So now we will see what is happening here. Let me clear this one. So I already told you I will discuss only the important one which is given in your Harper's Biochemistry. So we will talk with your uroporphyrinogen synthase 1. It will lead into acute intermittent porphyria. So these people will be having neuropsychiatric symptoms, right? Next, UPS3 deficiency will land into congenital erythropoietic porphyria, and these people will be having photosensitivity. I already told you, right? Some people will be having neuropsychiatric symptoms, some people will be having photosensitivity symptoms. Now, uroporphyrinogen decarboxylase will eventually lead to PCT, which is Porphyria cutanea tarda, and these people also will have photosensitivity because the porphyrinogen is taking a sideway pathway, and due to this sideway pathway there is spontaneous light oxidation and hence photosensitivity. Now deficiency in oxidases will eventually lead to photosensitivity. Okay. Now ALA dehydratase is can lead to lead poisoning, right? It is seen in lead poisoning, and ferrochelatase is also seen in lead poisoning. These people will have photosensitivity. So as you can see here, this table which is given in your Harper's, they are saying a simple thing. So basically, accumulation of ALA and porphobilinogen will eventually land in neuropsychiatric symptoms, whereas accumulation of porphyrinogens, which will eventually get converted into porphyrins, right? Porphyrinogens get converted into porphyrins by spontaneous light oxidation, and these people will have photosensitivity. So this was the cycle which is given in your biochemistry textbook. Now don't rely on this one, just watch what is happening. So hydroxymethylbilane is eventually getting converted into uroporphyrinogen 3. Now deficiency of uroporphyrinogen decarboxylase will take a sideway pathway like this, and in the presence of light it is getting converted into uroporphyrin. Porphyrinogen is going to convert it into porphyrin, especially uroporphyrin. Now I already told you this defective porphyrin will lead to tissue damage, and not only that, if there is oxidase deficiency, they also can lead to sideway pathway in the presence of light, and hence porphyrin rings are synthesized. And finally, as you can see here, Protoporphyrin is converted into heme by an enzyme ferrochelatase, and during this process iron is getting added. So lead can inhibit this ferrochelatase. So that was about your different types of porphyrias. Thank you for the